what happened in that last video? Well, I was just about ready to finish the testing of the swap out of the AD8009, as you saw. And then my old HP 54512 started to jitter, and it suddenly turned off, and though I didn't see the magic smoke, definitely smelt it. You know, basically it was my fault, as I've been long ignoring the warning signs. A year ago I noticed this. One channel not working correctly on a very old oscilloscope I wasn't too worried about. I've also had some other problems with it, namely the calibration signal started to be very flaky and actually stopped working just a few weeks ago. And every once in a while this message, "Warning, warning, warning, warning," would flash, as it was flashing just before the whole system shut down. Now, the really funny thing is that somehow my old HP oscilloscope knew things were afoot, as that very morning... Okay. Now, as I said earlier, well packaged anyway. I guess it didn't want to get relegated to the B bench, so it just gave up the ghost instead. Well, at least I have a subject for a future video. Now, let's get a little back on track. It seems that that AD8009 swap, right there, did fix at least part of channel 1. But I did notice that the signal at the 0.5 to 0.6 volt level was weaker than the other channels. So I had some progress, as it was non-existent before at that level. But the long and the short of it is, what I should have done, instead of sending all those emails back and forth, hoping to get the correct answer from FeelElec, was to take a little more time and trace out what is going on the board and do a little reverse engineering. What I really should have done was started out with a visual inspection of the board to try to figure out what's going on. And you can quite readily see there are 4 very easily identifiable sections. The power section over here, which we basically can ignore because everything else was all working correctly. An input section over here, which again we can ignore. There's nothing wrong with that section. An AWG, or basically the brain section. We don't care much about this section because at least 2 of the channels are working properly. And finally the output section over here. And basically there are 3 identical channels, 1, 2, 3. And each of them are connected to the AWG via a resistance capacitor network here. The same thing here, and I think this is it there. And I've discovered that there are basically 3 paths for the signal to go out. Directly to the relay and out, through the AD8009, or through the 3002 mystery chip. And from this simple examination, I could have created this. Put this to the side. I've zoomed out a bit. And there's our basic block diagram, all nice and neat. So basically we had the magic box AWG into some sort of voltage selector, and then one of 3 paths to out. The voltage selector basically works like this. 0 to 0.5 volts, out it goes. 0.5 to 6 volts, and out it goes. And greater than 6 volt goes through here. I'm not 100% sure if it actually goes through the 8009 chip and then to the 3002 chip at over 6 volts. But anyway, that's the basic way she works. What's actually going on is the voltage selector in the magic box never get above 0.5 of a volt. Whenever it flips between one of these stages, this magic box flips back down to the lowest level of the other offset. So armed with this block diagram, I would have been able to do some very specific probing on my board to find out what path exactly the voltages were going, and what voltages they were. And from that, what I should have done was create a test, like this one, where I have voltage going down here, 1, 0.01, 0.5, 0.1, 0.5, 1, 5, 6, and 10. Doesn't really matter after 5 actually. And then my channels 1, 2, 3. And then I would have had a basic pass-fail on any of these, and that would have given me a baseline to move from. Now, after I have the test done, what I should have done next, to go along with my block diagram, is do a basic schematic. Magic box, 89,000, 3200 relays, and just at least indicate where the resistors are. Fortunately, I didn't have to go back and redo all the ohming out and other looking at the circuit. That is because I took rather copious, though rather messy, notes for everything. You know, test what I was doing, blah 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 blah. You know, I have enough here for a good Bob Pease video, if you know who he is. Anyway. Now, of course, this is all just simple hindsight, as I did none of this when I was examining why my voltages for the AD8009 were not correct. I just tried to do this. Going to look okay. Let's walk her back now. This one. 50 ohms. 50 ohms. And this guy. Oh, 20k ohms. Okay, so there's something wrong with that one. Make a note of that. Aha! In the end, I did find that I had a bad resistor. It was actually reading 20k ohms when it should have been something like 9 ohms. That's the one right there. Now, the other big problem being that now I'm not sure if my original AD8009 chip was bad or just the resistor. I'll never know now, unless I put the other one back in, but I'm not going to start doing that silly stuff. So, at least I did learn my lesson when I swapped out that resistor, because then I went out and I created all those documents you just saw me, these documents here that you just saw me from my notes. And the first thing I did, after I swapped out that resistor, was do my test. And I got pass, 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 pass on the low ones, pass on the 5 voltage, and then fail on anything over 6 voltage as I expected. Channel 2 all worked fine, but then when I went to channel 3, suddenly I was getting a fail on channel 3. I just discovered a problem I never had before. And now that I had the schematic, I know that it had to be somewhere in this pair of resistors down in here. This trio of resistors down in here, not part of this circuit or not part of that circuit. So I was much quicker in finding that resistor, which was that one tucked right in there. Well, I know. So let's ohm these out and see. Turn that off. Get the ohm meter out. Could I have another blown resistor? So this resistor here is 500 ohms. And this resistor here is open. Okay. How much is this one? This one is 500 ohms. Well, 600 ohms. And this one is 600 ohms. This one 100 ohms. 100 ohms. 100 ohms. So this one here, I get another blown resistor. How about that? 0 ohms. Yeah, well, I'm going to do another swap out, which was actually surprisingly open. It was completely open, not letting any current through at all. Now I did that fix, and of course, because I had my lovely test sheet, I went back and did my test again, and the only fails I got were down here at the 6 and 10 voltage down here. So, and that just leaves me with this good old 3002 chip. We don't know where it's from or whose chip makes it. I've got to call out to them to say, hey, can you tell me where to get this chip? Can you send me a new one? Still waiting for that. But in the meantime, because I sort of had this problem with that and I wasn't sure what was going on, I decided to try and power up that op amp to see if it actually is working, and if there's not a problem somewhere else in this resistor group, or perhaps over in the relay somewhere, or even a blown trace someplace. And here's what I did. On pin 7, inject here, okay, and inject here. Okay, I'm getting something. You know, the more I look at it, the more I think that op amp is perfectly fine. Must be something else that's screwed up, because that's the same as I was getting over there. Yeah, but see, that's not right. Ah, okay, so that one's not getting anything. Okay. Yeah, you see, that is different. I should be getting the inverse. Either side, I should be getting that small one and then a big one. And this one, I'm only getting it cut off, so it's not summing. So I'm not getting anything out of the summing side. Yeah. Increasing the voltage all the way up to say 5 volts. We get it flattened. Yeah. So that definitely tells me that op amp isn't doing anything. It's not actually summing those two up. Because I should be getting something like that and something like that, but all I'm getting is a big one and a similar size big one. Alright, so we know that op amp is dead. Okay. So what I was doing in that test is I powered up the op amp on pin 4 and pin 8. Then I listened for a signal on pin 1 while injecting a signal first in pin 3 and then in pin 2. And I got the expected results. When injecting a signal in pin 3, I get a large signal out, and when injecting a signal in pin 2, I got a small signal out. I tried the same thing for the other side of the op amp, and when I injected a signal into pin 5, I got a large signal out on pin 7, and when I injected a signal in pin 6, I got the same signal out again. So that was telling me that the op amp was obviously dead. And as I mentioned earlier in the video, I sent off my final email off to FeelElec, and hopefully I get some sort of reply from them. Riley? Riley? Are you getting motivated to do more videos and work? Nope. Nope. No more videos or work? You really want to help out? No more helping? Oh well. Why don't you just go back to sleep then? Alright, see you later, Riley.